This is week 10, lesson 2. We are going to be solving absolute value equations, both algebraically and graphing. All right, so let's start with example 1 right here. And this should be a review lesson. I'm not sure why that doesn't want to zoom in bigger, but that's okay. I'll just deal with it. Okay, so in order to solve this equation, I need to isolate the absolute value. I need to get it by itself. Do not, under any circumstances, distribute that -2. Okay? Do not. Resist the urge. Resist. Okay, so first I'm going to move this 2 to the other side, which gives me -12. Then I'm going to divide both sides by -2, which gives me 6. And then, if you remember, since absolute value is a distance from 0, that means that that absolute value could equal 6, or it could equal -6, right? The stuff that's in the bars could either equal 6, or it could equal -6. And I wish that was a little bit clearer. Let's do that. There we go. All right, so solving this, I get 3x equals 0, or x equals 0, and 3x equals -12, or x equals -4. All right, now, I know you hate this part, but you need to check it, okay? You need to actually plug that back into the original and make sure that it actually works. I'm going to leave that to you, but these do both work. And I'm going to show you why. Okay, I'm going to show you why on the next example. Okay, so let's solve this algebraically, right? Kind of the way we just did the last one, where the stuff that's in the absolute value could be the original, or the stuff in the absolute value could be the opposite, right? That's how we solved the first one. So solving this, we get 3x equals -6, or x equals -2. And this one, solving, we get x equals -4, right? They both seem fine. They both seem great. But look what happens when we graph this. Okay, so this is what I'm going to do. I'm going to graph the left in green, and I'm going to graph the right in pink. Okay, so the left in green, absolute value that has been moved left 1 unit. So I've got these dots. I will use a straight edge to connect them really quick. Give me a sec. Hopefully this works. Sometimes it's temperamental on my iPad screen. Okay, so there we go. I've got the green one graphed. Now the pink one is a line. It has a y-intercept of -5, 2, 3, 4, right here, and a slope of -2. Okay, so when I am trying to figure out where these two things are equal, right? That's what that equal sign means. The only spot where they're actually equal is right here, right? And that x value is this -4. The -2 is just an extraneous solution, okay? This is why you have to actually plug it in, plug it back into the original, see if it works. Because even though mathematically it seems like it's right, it's extraneous. Okay, now this last one, we could do it algebraically, but I think I would rather show you how you can do this on your graphing display calculator, I'm not sure what IB calls it. Is it GCD, GDC? I don't know. But anyway, I'm going to switch over to the calculator and show you how to do this one. Okay, so for the last example, we're going to be using our graphing calculator. What I have done, actually, let me get out of here. What you're going to need to do is to get into your graphing sort of menu, which is right here where it says y equals, and you're going to be graphing the two absolute values that are on the paper. Okay, so in order to get the absolute value bars, I'm going to hit second and then catalog, which is right above the number 0. And option number 1 is absolute value. So you'll see they sort of magically appear right there. We're going to type in 3x minus 4. So 3x minus 4. Then we're going to scroll down and type in the other one as well. So I'm going to hit second, catalog, grab that absolute value. And the other one we're graphing is 2x plus 3. So 2x plus 3. And when I go up to this graph button, they should appear. Now, my guess is that yours isn't showing as much as mine is showing. And to do that, to get it to show everything, go ahead to Zoom. And if you scroll down, you'll find something that says Zoom Fit. All right, see it right there, Zoom Fit. And if you hit enter, it'll change the window so that you can see the intersection points. Okay, so now what I want my calculator to do for me so that I don't have to do a whole bunch of algebra is I want it to calculate the x value here where they intersect and the x value over here where they intersect. So I'm going to hit second and trace, which brings up this calculate menu. And I want option number 5, which is intersect. And you can either use the down arrow to get there, right? Or you can literally just type the number 5 and get there right away. Okay, so now what the calculator is saying down here, there's some words. It says, which is the first curve? Now, I'm lucky, I only have 2 curves in there, but you may have, let's say, 7 different graphs in there. So you need to make sure to tell it which one do you want it to use. So I'm going to say, yes, the blue one, and mine's nice and color-coded. The blue one is the first curve. And then it's asking, okay, well, is the second one the red one? And I'm going to click enter. And then it's asking me again, it's sort of talking to me, do you want me to guess what the intersection is? And I'm going to say yes. And there it is, x equals 0.2 or 1/5, right? 2/10 is 1/5. So that's one of your solutions. But there's another one over here. All right, so I'm going to go back to that calculate menu. I'm going to pick option number 5 again. And this time I need to move the cursor. You can kind of see a blinking cursor right here. I'm going to move it using the arrow closer to the other intersection point, right? You're pretty much telling your calculator, hey, I still want you to find the intersection, but over here would be great. So let's hit enter. Now notice when it goes to the second curve, it automatically puts the cursor closer to the first one. So let's hit enter. When you're asking it, hey, do you want me to guess? Yes, I do. And there's the other intersection point. So the 2 answers to the third example are 1/5 and 7.